Hello everyone, this is a video on the absolute value of a number. And before I give a specific example, let's just assume that that number is represented with a. And that will be and the definition of the absolute value is the distance of a, whatever that number, positive, negative, or zero, from zero. So let's just do a few examples underneath. What would make sense is just to have a number line in front of us. Let's just put the 0 here in the middle. And if I want to calculate the absolute value of 5, of course, let's just put 1, 2, 3, 4, 5, 5 here. Then this is what's the absolute value of 5, right? It's the distance from 0. So, of course, the answer is going to be 5. Now, if instead of a positive value, I choose a negative number, let's say negative 3, then 1, 2, 3, negative 3 goes to the left, then that distance, right, which is the absolute value of negative 3, because we're talking about distance, and distance is always positive or worst case scenario 0 when we have the absolute value of 0 or the distance of 0 from 0, then that will also become equal to 3. So therefore, you do understand the first property, because I want to talk about the properties of absolute value next, that the absolute value of a, whatever that value of a might be, is always going to be bigger or equal to 0 because it represents distance from 0. And that's the first takeaway regarding the absolute value. Now, what's an interesting idea that it seems to confuse quite a lot of people is when we are given the distance, but we don't know what number this is going to be. Let me just make myself clear because it sounds pretty complicated. So what is x, or find x such as the distance from 0 to be equal to 6. So let's just give myself some space, make a new number line. That's the 0, 1, 2, 3, 4, 5, 6. And then obviously the absolute value of x is equal to 6. That means that one answer would be that the x is equal to 6, right? Because here we have that one number that is 6 steps away or 6 units away from the 0 is number 6. However, and that's the confusing part, there's another number that is also 6 units away from 6, and that would be the minus 6. So therefore, we have two answers. X is equal to negative 6, and that's because, if you want to write it a little bit more formally, that's because the absolute value of 6 is equal to 6, and the absolute value to negative 6 is also equal to 6. So that's an important property to understand. When you are given a specific number and you want to find the absolute value, then you are looking to find the distance of that number from 0. Like in the example 1 and the example 2 with the negative, the answer is always positive or 0, and that is because you might be given a variable that the final answer is equal to 0. But then when you're working backwards, find the number that has distance from 0 to be a specific number like 6 or 5 or 10, then please do be aware that you're going to have two answers here for that case. So let's just carry on with the properties of numbers, properties of absolute values. So property number 1, the absolute value of a is always going to be bigger or equal to 0. Well, we already said that the absolute value of a is going to be the distance from 0. So if you think about number line and the 0 here in the middle, let's pick up a point at any point that we want on this number line, and let's assume that that point is going to be sitting somewhere here. I don't know what this number is going to be because I haven't specified it, but I know that the absolute value of that point, let's put it the absolute value of x, it's going to be bigger than 0. Why? Well, because there's a distance between the x and the 0. And if I choose another point and just put it kind of like, here, and I put that point y, then the absolute value of y also is going to be bigger than 0. So why do we have that equal to 0? Well, because we might be having a point that is right on top of 0. And that's the only reason. Property number 2. The property number 2 is like positive and negative numbers, that they hold the same numerical value, but one of them is positive, the other one is negative, they're going to have the same absolute value. I think it's easy to understand that the absolute value of negative 3 is going to be equal to the absolute value of 3, and in this case it's going to be equal to 3, because both negative 3 and 3, they are 3 steps away from the 0. Now, number 3 and number 4 are quite interesting ones, and I guess I'm not gonna go into a formal proof, but what I will do, I will choose those and I will make an example. So let's just see. Let's assume that the A is equal to 4, and let's assume that B is equal to negative 3. Let's just see what the absolute value of the product will be, which is the property number 3. Okay, so let's start with the left-hand side. That would be the left-hand side, and that would be the right-hand side. And that's a terminology that's used in the IB a lot. So for the left-hand side, I will first calculate the product of A and B and then the absolute value. Or I can just substitute, but let's just do the A times B first, which is going to be 4 times negative 3, and that's going to give me a negative 12. And then once I calculate the absolute value of A times B, that's going to be the absolute value of negative 12, which is equal to 12. And that's going to be the left-hand side, like we said before. Let's just test the right-hand side. So the right-hand side, I need to calculate the absolute value of A, which is equal to absolute value of 4, and that will be 4, and the absolute value of B, which is the absolute value of negative 3, and of course that's going to give me a positive 3. So when I calculate the absolute value of A multiplied by the absolute value of B, that's going to give me 3 times 4, which is equal to 12. Left-hand side is the same with the right-hand side. Therefore, we can see that the property number 3 works, right? And that's the property number 3. And then if we do the same with the property number 4, so first let's calculate the A over B. A over B, that's going to become 4 over negative 3. Let's write it as negative 4/3. What the absolute value of A over B is going to be, it's going to be the absolute value of negative 4/3, which is 4/3. And that's for the left-hand side for the property 4. Right-hand side of the property 4, the absolute value of A, which we've calculated earlier for the property 3, that's going to be equal to 4. And then if I divide by the absolute value of B, which again I know that is equal to 3 from the example before, then I'm going to have the absolute value of A over the absolute value of B equal to 4/3. Again, left-hand side is the same with the right-hand side. That's one example that shows that the property 4 works. Again, obviously, assuming that the denominator is a non-zero number, because if the denominator of any fraction is a 0, then we have a problem there. Finally, we're going to move on to the property number 5, which looks a little bit more complicated, mainly because of the inequality symbol that we see here. But let's see how this is going to work. So let's just keep the same values that we had before for 4 and negative 3. Now we can see them on the screen. And then let's just test the property. So for the left-hand side again, what we have the property of the absolute value of A plus B. That would be equal to 4 plus negative 3. Obviously, 4 plus negative 3 is 4 minus 3. Let's just write that too. 3, which is equal to the absolute value of 1, which is equal to 1. And then the right-hand side, we have the absolute value of A, which is equal to 4. And the absolute value of B, which is equal to 3. And then obviously the A plus absolute value of B, that's going to give me 7, which means that my property for these specific values works. I mean, it works for every value, but let's assume that it's kind of like, we just choose one example just to see what's going on. So we have the absolute value of 4 plus negative 3. Let's make the absolute value slightly bigger. It's smaller or equal. In this case, it's only smaller, not equal. We will discuss about the equal later, than the absolute value of 4 plus the absolute value of negative 3, which is equal to 7, right? Because we have 1 smaller than 7. So the little question that's been raised in this case is like, when are these two are going to be equal? Well, I can give you a bit of a prompt. Think about what happens if one of the numbers is equal to 0, or both of the numbers is equal to 0, and perhaps take your time to kind of like, just do an example and see which one of those cases is going to work, or both, or none of them. For this last part of the video regarding the absolute values, I wanted to talk a little bit about like what we actually do with this, and with the absolute value, how we gonna come across them. And we dealing with absolute values when we're dealing with either equations or inequalities, or even absolute values regarding functions that I'm not going to talk about in this video, as this is slightly a little bit more advanced. But at the end of the video, I will, or at the description, I will link a video of an activity that is just like really interesting from underground mathematics. Please look for the link on the description below. So let's just talk about a little bit about equations. So one of the properties of the absolute value is that when you have the absolute value of a number a to be equal to b, or that means if the absolute value of a is a number that is b steps away from 0, that means the following two things: that value of a is going to be equal to b, or value of a, not b, value of a is equal to negative b. And this is a property that we use when we solve equations. So let me just give you an example. Let's assume that we have 2x minus 3 inside an absolute value is equal to, let's say, 5. Then the one way to get rid of the absolute value is by using the property above, because that would result into two different equations. Equation number 1, which is going to be the 2x minus 3 is equal to 5, or 2x minus 3 is equal to negative 5. And then we solve those two equations separately. So if we add 3 to both sides, then that's going to give me that 2x is equal to 8. And then when I divide by 2 both sides, x is equal to 4. So 4 is a number that if I plug back into the absolute value, that would create a number that would result into a number that's going to be 5 steps away from 0. And let's just try it. So the absolute value of 2 times 4 minus 3 is equal to the absolute value of 8 minus 3, which is absolute value of 5, which is equal to 5. That works. And then we're going to have to solve the other side too. So again, add 3 to both sides. That would result into 2x is equal to negative 2. And then if you divide by 2 both sides, you will end up with x is equal to negative 1. Apparently, this is the other value for which the absolute value of that equation we have, it's going to be equal to 5. So let's just test that part too. So my equation would become 2 times negative 1. Always when you substitute negative numbers, use brackets, by the way. That will get you out of a lot of trouble. So that would be negative 2, negative 3. That would be equal to the absolute value of negative 5, which of course is equal to 5. And that also works. That's an incredible thing to put it in your head as a structure, that when you have an equation, then when you're solving with the absolute value, almost all of the time, unless if you end up kind of like, with a value that's going to become equal to 0, but almost all of the time you're going to end up with two different values, if not all of the time. And then if we don't, when we're not dealing with equations, we're going to be dealing with inequalities. But before we get into working with a couple of examples with inequalities, we need to discuss first the properties that we're going to use in order to make some progress with these inequalities. So the first property for the inequalities plus the representation of the solutions is that when the absolute value of a number A is smaller than B, or is less than B steps away from 0, then that means that value of A is smaller than B and bigger than B. What helps here to understand what this property is saying is always a number line. So let's just put the 0 here. And let's assume that this B is somewhere that long. So this is like the B, right? It is, I guess, easy to understand that any value that's going to be positioned between 0 and all the way up to B will fall into this sort of property, any absolute value of a number A. That means that the absolute value of any A that's in this highlighted with red part, it's going to be smaller than B, right? But there's another part though. So if this is the plus B steps away on that side, then we have another minus B steps away down here. That's going to bring you down to minus B, right? And the same thing that applies before about the distance from 0, it applies for the negative side as well. So what I mean by that is like any number on the highlighted part that I'm highlighting now is also going to be the absolute value of all of those numbers. A is also going to be less than B steps away. So the actual solution for all the A's that they are smaller than B's, they're all the A's for which the absolute value falls into the category here. Now, how do we use that property? Well, let's just make an example. Let's just put 2x minus 3, absolute value, is smaller than 8, right? Because we have an inequality here, we can use that property, and the result of it would be that 2x minus 3 is nested between the value of 8 and the value of negative 8, because these are all the numbers that they have distance smaller than 8 steps away from 0, right? So all of those numbers, they have to be anywhere between minus 8 and 8, as was demonstrated a bit further up. Now you have a double inequality, obviously, that you're going to have to solve. But the one thing you have to remember about solving inequalities, if you don't know already, is that unless if you multiply or divide by a negative number, then the signs would not really change direction, which is actually what's going to happen in this case here. Let's see. So we have to add 3 to all sides because we want to isolate x, right? And those 3's, they cancel each other. So you end up with 2x in the middle, smaller than 11, and bigger than negative 5. And then we will divide every side by 2 because, again, we want to isolate x. So you end up with x is smaller to 5.5 or 11 over 2. There's nothing wrong with that. And negative 5 over 2. And that would be the solution. What does this mean? We get a range of solutions. And that means that any number between negative 2.5 of negative 5 over 2 and 5.5 is part of the solution of the question that we begin with, which was this one. And if we want to represent the range of values, we have to use the number line. Let's put here 0. Let's put the negative 2.5 somewhere here. That's going to be the negative 5 over 2. And then let's put the 5.5 somewhere on the other side. So 1, 2, 3, 4, 5, 6. Let's just put it here. I said I'm going to use the fractions. 11 over 2. right, which corresponds to 5.5. Now, I want all the x's that they are housed between the negative 5 over 2, but not equal to 5 over 2. And to represent that, we're going to put a circle that is an open circle, right? That means that in my solution, the negative 5 over 2 will not be included. And then the 11 over 2, we're going to do the same thing, an upper circle, and then we can join those two. And that red line with the two open circles on the other side represents the solution of the inequality graphically. Now, it is worth noting that if we are solving an inequality and after a series of calculations, we ended up with x bigger or equal to 3, then if I want to represent that range of solutions, and I put the 0 here, and then 1 and 2 and 3, that's going to be my 3, then what I can do, I can put a circle with the 3's, and then fill in the circle because the value of 3, it is part of my solution, and then just draw a line with an arrow pointing that this is the range of solutions for x, right? So be a bit more careful whenever you have like an equal involved into the equality, or we just have either a bigger or a smaller than a specific number. Finally, look at the link that I'm going to share with you for an activity from underground mathematics. That prompts you into discovering a little bit more how the absolute value can be used in functions. And I know that I haven't talked about functions yet, but like I said before, this is partly to cover prior knowledge, so I'm assuming that some of you already know what is the function and why it works. So you can use underground mathematics and Desmos to plan a couple of to play around with the functions and see how the functions are going to look like, and sort of start considering a bit higher level, more advanced sort of mathematics regarding the absolute values and the functions. That's it for now. See you next video.